We all know what light looks like, but it's also just one tiny part of an invisible spectrum. We can only see a tiny portion. The rest includes things like radio, X-rays, and gamma rays. So this is how light fits into electromagnetism. From the last video, you know that Maxwell's laws predicted these two things. A changing electric field and changing magnetic fields create each other. And these self-sustaining waves travel at a speed of c, which is 3 times 10 to the power of 8 meters per second, the speed of light. And the measured speed of light at the time matched this number. So Maxwell made a bold claim that light itself is an electromagnetic wave. A few decades later, this guy named Hertz proved it with an experiment. All electromagnetic waves move at the same speed in a vacuum, which is the speed of light. And it's given with, if you remember back from waves and oscillations, the wave speed formula was this. So this is how fast an electromagnetic wave moves in a vacuum. And this formula is on the free cheat sheet in the description, but the wavelength is this simple, and it's roughly 400 to 750. That's what we can see. And the frequency is somewhere around 4 times 10 to the power 14 to 7.5 times 10 to the power 14 hertz. But this is a tiny slice of the full electromagnetic spectrum. For example, radio has a frequency of 10 to the power 3 to 10 to the power 9 and a wavelength of over 1 meter. Infrared, which is what your TV remote uses, and it's why pointing your TV remote toward the TV works a little bit better. Infrared has a frequency within 10 to the power of 11 to 10 to the power 14. And the wavelength is somewhere in the micrometers range. There's also stuff like X-rays, gamma rays, microwaves, and all of them are electromagnetic waves. The only difference is the wavelength and the frequency. So how are these made in real life? Radio waves and microwaves are made in labs with antennas and oscillating circuits. Infrared to ultraviolet are usually emitted by electrons with jumping energy levels. And X-rays or gamma rays are from nuclear stuff or high-speed deceleration. And even a light bulb filament only emits visible light because its electrons are vibrating really, really fast. Let's go to an example problem. If a laser is shining light at a frequency of 6 times 10 to the power 14 hertz, what is its wavelength? The speed of light is equal to wavelength times frequency, and we can rearrange for wavelength to get c over f. C is speed of light 3 times 10 8 divided by the frequency 6 times 10 14, and the answer is 5 times 10 to the power of negative 7 meters, which is 500 nanometers. And this is green light. Green light is right in the middle of the visible spectrum. And I'll give you a real-world implication. A phone call from New York to London will take roughly 0.017 seconds if it travels by cable. But if you call via satellite, then it's got to bounce up and then down to London, which is much slower. It's roughly 0.24 seconds. It has to bounce roughly 72,000 kilometers in a round trip. And this delay is not because the signals are slow. Electromagnetic waves are extremely fast. They move at the speed of light, but space is huge. So all of these electromagnetic waves, they all travel at the same speed, and they're born from accelerating charges in the self-sustaining cycle between electric fields and magnetic fields. But the difference is energy and frequency.